this next talk is by myself. I'll be focused on offline databases or browser databases. And I will win the award for the most horrible slides because they're not pretty as all the other presentations. They're just a lot of code. So hopefully you guys like to see a lot of code. Give a brief background for those who don't know me. I'm Tom Wilson, lead technologist at Jack Russell Software. On Twitter, you see me as TWilson63, and at GitHub and pretty much everywhere, TWilson63. I focus on JavaScript, love JavaScript, and try to do everything in JavaScript. So, and that includes offline. So there's a little bit of a spark of a movement to move or experiment with this idea of offline web and the ability to use tools that you use being connected day in and day out in an offline capacity. And that may be anywhere from being on a train or on a plane, even though you can use that now, and there's actually people that complain about how slow Wi-Fi is on a plane. Just think about that for a minute. You're 30,000 feet in the air and you're complaining that your YouTube doesn't play fast enough. Kind of crazy. But basically, there's one use case, and then the other side is just to realize that the internet is a global thing, and we're very fortunate where we live that we are able to get on the web very freely, but there's a lot of places that can't, and and actually even if they can, it's very expensive. So I think there's a lot of opportunity there. And then the last thing is our users are moving and using the web everywhere. And even if it sort of slows down for a minute or two, they get frustrated, whether they're on their phone or on their tablet, anywhere. So mobile latency and dead zones. And so the offline web has been started for a few years now, and here's some of the tools that are out there are in the works. App Cache is a tool that essentially allows you to provide a manifest file that says, I want all of this stuff to be stored in cache on the client system. Now you have to be careful with that, because if you don't know exactly what you're doing, they will be on that client system forever, and you will not be able to update them. So there's a new proposal out there. It's landed in Chrome, but it's I don't think it's fully in all the other browsers, even though there's a lot of promise. I think IE Edge has it as well. It's called Service Workers. And it's basically, if you think of App Cache is the very easy implementation, very opinionated. Service Workers is the low-level utility belt where you can orchestrate your whole offline experience by leveraging Service Workers. And I can't talk to a lot of great detail about Service Workers other than I sort of picture it as any request coming from the browser. The Service Workers can sit as a middleman and either choose to route that request locally to pull assets or route that request to the internet and pull assets. So that gives you a lot of flexibility and power and control on how you manage your needs for offline support. And then the other three are mainly storage layers. Local storage has been around for a while, and it's basically a synchronous key value store. Somewhat painful, right? Because every time you pull something out, you have to either parse the string or set the string back. So it's not very smart. And then you have Web SQL. How many people have played with Web SQL? Back in the old days, and it's still around. And there's some browsers that haven't implemented anything else but Web SQL. And then IndexedDB, and that's pretty much in every browser except, I want to say, even Safari has IndexedDB. It's just a very buggy version. But those are the tools that are in the platforms today. And all of them have different strengths and weaknesses. I want to focus on a tool that sort of sits above those and not focus on the app cache or service workers, but really on the database side and storing data. And that tool's PouchDB. PouchDB actually is a full implementation of Couch, or the replication I/O protocol that sits on the browser. And it actually sits on top of IndexedDB, or Web SQL, or local storage. So you can write just like you would be writing to one library, PouchDB, and choose where you want it to be stored, right? So you could say, I want it to be stored on local storage, or I want it to be stored on Web SQL, or for this particular browser, maybe stored on IndexedDB. And the other interesting thing is, since it's written in JavaScript, it actually runs in Node. And you can have it sit on top of a level DB, which is the same database engine that Google uses for IndexedDB. And to take it to even a more insane level, you can have it sit on top of virtually any driver of any database that you can connect to in Node. So you can have it connect to DynamoDB, or you can have it connect to React, or you can have it connect to MySQL, and run the same API off of that. So that's really interesting. And the interesting thing about it is that the protocol that was really originated from CouchDB is called replication I/O, and it makes it very easy to exchange data and keep data in sync on various different platforms. It works in virtually every browser. It's very lightweight. For, if you think about a database, 46K is pretty light for a database. Although the other day I saw SQLite introduce something, full text search and one other thing, and they still, I think, stay under a couple of megs in footprint, which is kind of amazing. I think they have like stored procedures and views in there now. Crazy. Oh, JSON. They introduced JSON objects in SQLite. And I think PouchDB is easy to learn, so we'll step through a little bit of that today. I figure give you some use cases, and then we'll actually walk through some code so you can see some actual examples of how easy it is to use PouchDB. And it's open source, and it's a very rich, fully community-driven open source project. It's pretty amazing. When you're working with PouchDB, basically you can install it several different ways, and when you install it, you can include it as a script tag, install it with one of the tools that we've learned about today, Browserify or any of those tools, and Webpack. But then once you have access to it, basically to create a new database, all you do is new PouchDB and the name, and if the name does not have a URL, it will create that database locally. When you do create it, though, you can also specify options of what kind of database adapter you want to use. If you pass in a parameter that's a full URL to, let's say, a CouchDB server or a PouchDB server, then it becomes an API driver. So what's really nice about that is if you're using any replication I/O server on the back end, you really get the benefit of the term universal JavaScript, right? So you're writing the same code and sharing it on the client and the server, and really dealing with moving your data. So oftentimes you're going to write code to take on the server side your data and put it into a persistent store, and then you're going to write code to pull that out. And when you go to the client, if you want to facilitate and provide a need for that you don't want to have to learn a whole new construct to do that. So PouchDB gives you that API. And then the last line here is replicate to. So when you call that line in PouchDB, immediately everything from your local database will sync and replicate to your server database, all of your changes. And you also have what's called a changes feed, which is not common on a lot of the databases today. And basically what that does is every time there's a change in your database, you get notified. You can handle that change. And several of the databases now are starting to implement similar features. I know SQL Server and Postgres, I believe Mongo is starting to introduce a change, and another database, RethinkDB, takes it to a whole nother level with the changes feed. But that's kind of cool to be able to sync your changes. So I'm going to walk through creating an offline app, and I'm going to just put the link to the app here to pull down. But one of the things, just like all things that happen, is for some reason everything was working until the last 5 minutes of your talk, and it's not working. I don't know if it's the connection here or whatever, so there's not a big thing to show, but I can talk through the app and show you the use case, and you can take this and actually play with it. But basically the app would ask you to log in with your GitHub account, and then it would use the GitHub API and pull down all your starred repos. And it will store those starred repos in Pouch in your local browser, and also pull in all the readmes of those repos so that you could be completely offline and read through your readmes of all your starred GitHub accounts. And it will keep those in sync. So the code does work. It just doesn't work right now. But I think I can work through that. And this link will be the actual app in play. And I do have people that will vouch for me that it was working yesterday. It was working great last night. But anyway, it's really more of the concept. So one of the things that you may be asking is, we've got all this data. It always needs to be on the server. Why would we really want a database in our browser? That sounds kind of crazy. And I look at things like from real world experiences. I think of type aheads all the time. If you're building type aheads and you have to, you never know when it's going to take a few milliseconds to, maybe 1,000 milliseconds, depending on where that user is. And when they're typing something and they're looking for suggestions, it can be very frustrating if they have to wait for the server to do that. And if you have a smart list, why not, while that user is doing other things, pull down those suggestions behind the scenes, load it in a database on your browser, and use the exact same code that you're using on the server to build your type ahead. And literally the user would get instantaneous responses in their results, and your server's not getting pounded by people misspelling words all the time. So I think that's one real value that we're taking with us and working on implementing, because we have a lot of clinical data like medications and allergies, and those lists don't change but every month. So why constantly run a MySQL query when the data is never changing, and then put a cache on that and manage that cache when the real cache is, you can just throw it right in the browser. So that's one. I happen to think that there's a lot more cases coming out as we grow, and we were talking at lunch of just the idea of doing everything in your browser, right? And being able to move to multiple computers. If you have all of your data, whether you're working on your blog post or you're working on other things in your browser, as shared data, and it can push up to the server without having to think about it. That's a very, very powerful concept. So I think that's another good use case, and I think you can think of a lot more. But just to walk through a basic to-do app, here we have JS bin, and what I'm going to do is sort of just comment these lines of code and just go through the step-by-step what we're doing. And the first step, basically, we're creating a new couch database. So now that I've run that step, I should be able to go into my console and just type DB and see that my couch database is in there. And we have a little flag set for remote couch being false, or my PouchDB, sorry. So the first thing we want to do is add a to-do to our to-do list. So we just create a function, add to-do, and we're going to create a object, give it an ID, a title, and a completed flag. And then we're going to call db put and put that document into our local database. And then this particular instance is using callbacks, but it also supports promises as well. And we'll handle the error. And then we've just got a little function that will just write the things out nice for us. So let's see here. So you can see that it executed and it actually stored this JSON document in the database and returned a true, and an ID, and a revision number. And if we wanted to list all of our to-dos, we can just add a function here to show to-dos. And in this case, we're just going to query the database for all the docs in the database. Show to-dos. And you can see that we've got one to-do in our database. Let's see. And to know where it's stored, so the default couch or pouch database is stored in IndexedDB on Chrome. So we can go into our resources and we can look at IndexedDB and we can see our to-dos app that's stored, and we can go in and see our documents in there. And there. Add to-do. To-dos. Okay. And you can see I just cleared the session and reset it, but you can see that our database still stays persistent. And then if we wanted to change a document, we can just call our checkbox change function. And then hopefully our show to dos will list out that it completed. So in the example that I used, and I'm gonna go over to some of the code and just talk through it. In the example, it's using a factory in AngularJS. And in that factory, it's using a plugin called Upsert. And what's happening is when it goes to get all of your starred repos from the API, it's essentially, as it's building that list on the screen, it's adding those documents locally into your Pouch database. And let's see, I can show the school. So then that way, so here it's making a post to get all the repos with your given access token, and then it is using promises to take that data and store it locally by calling this local function. The local function, all the local function is doing is just upserting the document in the local store. So then that way, if for some reason the user's unable to see the server, then when the next repo request is called to generate that list, it's got a catch. And with that catch, it goes and looks locally and says, well, let me get all the documents that are stored locally and display those to the user. And that way, this is just a really naive way of keeping those lists in sync and showing your Pouch stored documents when your server is not available, right? And then the other thing that it's doing is, as it's building the repos list, which needs some of Stokes performance monitoring to see how performant this is, but it is actually going and grabbing all of the readmes from GitHub for that, and it's actually pretty fast when it's working. But basically then it's taking those README documents and inserting them into a document store for retrieval. And then this particular factory is shared by a couple of components. So we've got the repos component that's just building the list. And when you click on the list, it shows a README component. And in that README component, it's presenting the README. So when it makes a call to the factory to deliver the README, it will go into the factory function and call this function README, passing in the access token and the name, and it's going to make a post to the API and get the READMEs. So to do offline mode, since I've already downloaded the READMEs, basically I can comment this code out and uncomment this code, and now it's going to call the README database and get the name and return the README right there on the local system, right? And the nice thing, again, this is a very naive example, but the nice thing is every time I open my list page, if I'm connected and I got a fast connection, I'm re-syncing my local database with the most recent data. Now with Pouch, you can get more elaborate, where you can actually run live syncing to remote databases by just giving it like the replicate to command, giving it a sync true, and it will essentially use long polling to sync your server database and your browser database and keep all of those in sync. But I think the overall thing about it is that this API is very approachable, very easy to do, and it's very powerful. You don't have to write a lot of code, and it's real easy to manage. It's just managing JSON documents, which we do all day anyway. And you can use MapReduce to do your queries, but you can also use the Mongo-like query search language as well, where you can ask for give me all the fields where X is greater than Y, or give me all the data where the date is between this range. So you have access to all of that power right there on your browser. The last use case that I've really found effective for the last couple of years is, as Brian was talking about prototypes, we don't have a lot of those fancy tools to do the images and high fidelity, but the thing that I could do with this is basically focusing on the front end, build a prototype in code very quickly and not have to worry about, do I have servers in the back end provisioned and things like that, and also to someone's point earlier, build a rich type ahead or build rich text and show how that transitions between pages by just using this API. And in often cases, I can take an application, even though it's a very simple one, and build it all in the front end. And then when I get ready to move it to the server, it's changing literally one line of code from PouchDB to-dos to PouchDB server.com to-dos, right? So that's, in my mind, very, very powerful, coming from a world where you have, sort of a lot of constrained schemas that have to be defined up front that goes into really high models that have to be built that's then attached to controllers, and you have to build all of that stuff up before you can connect one form to send data to your database. So to me, this sort of changes that paradigm and allows you to start sort of interacting with your app before all of that's baked in. And oftentimes we deal with situations where naming things is really hard, right? So if, again, an example in my world, let's say certain users want to see things named as patients, and other users want to see things named as participants, and other users want to see things named as members. Well, the first thing you do when you're building a rich schema in a relational database is you want all your columns to represent what the users are going to interact with. So once you name those columns, and then over time as they work with the application as it's being built, they start to change their names, becomes either you've got to change a lot of code, just because the name changed, or you have to live with that and just sort of create a mental switch and say, oh, well, it may say members in the database, but it really means patients on the screen. And you have to teach all your developers to make that switch. So over time, as your developers come in, more developers come in, they're like, why are we calling black on the screen and it's really white in the database? And how can we manage that and reduce bugs? So I think bringing NoSQL documents, at least on the prototype and the early development stage, is a much better way because, again, you can change your schema so much quickly on the browser. And once it starts to bake in, then if you need that relational system, you've got a spec right here, all in JSON documents defined on what your relational system should be. And you actually have users actually using it, proving that. So I think not only is offline databases and offline web, sounds crazy, but sounds like a lot of fun too. The fact that you have really direct needs or use cases right into your development workflow is pretty powerful. Even if you're like, there'll never be the need to have a database in the browser, right? But I really think that more and more use cases, especially in areas like disaster recovery, being able to have peer-to-peer databases and share information when people are trying to help and keep in touch is something that you can't have internet. There's no electricity. There's no connectivity. There's no tower. So that could be kind of interesting.
Tom,
Yep.
so I think your app might actually work. Is it supposed to do that?
It is supposed to do that. Is that on Heroku?
Yeah, on Heroku, yeah.
Okay, cool. Yay.
So maybe something in your instance or something.
Yeah, I really, looked at it like 5 minutes ago and just totally freaked out.
You try like IndexedDB.
Yeah. I was like, this is working, and then so I think I'm like not on the right network or something. But anyway, the app is working. The code is on the GitHub repo, and basically you can log in as your GitHub account, and it will pull your repos down, and then you can click on the repo and see a README. It's a real simple application that works on everyone's system but mine. So that's.
You have to like log into the.
I need to restart.
I used the one up there on the board earlier.
I use that. CDC guess.
So if you go to like a non-SSL site and then you click accept, it should like.
Look at what? Look at the.
If you go to like a non-SSL site first, and it has like an agreement page.
I got you. I got you.
Like heavy.us.
Um,
Don't show that up there.
Yeah.
Yeah.
I guess you're already in.
Looks like you got some screen jank.
Yeah. But there it is. Yeah. All right. So if I had it completely offline, I wouldn't have had this issue. But anyway, basically, you should be able to play with the code and see how it's pushing things in the database, and you can see down here we've got some errors. But you go into IndexedDB, or you can go into your console and query it as well if you make your PouchDB a global variable, and you can see what's going on. But it's, the technology for Pouch is pretty mature at this point. It's 5.0, and this one plugin persistence engine called Fruit Down is very interesting because they just released that, and that connects to the IndexedDB on Safari. And one of the limitations with browser databases on iOS is the 5 meg limit. This Fruit Down plugin will connect to IndexedDB on Safari and get rid of the 5 meg limit. So you can overcome those types of things. But I do think you're going to see a lot more innovation in this space and see a lot of the users asking for things to be offline, and they're going to come back and say they want it faster, right? And they want it to not time out in certain areas, and you're not going to be able to reproduce it in your lab because you're going to always have fast Wi-Fi and fast connectivity. But by providing things that you can predict, like there's some companies that actually will start firing off events as the mouse moves towards a certain location and pulling down data on demand as you're moving towards there. If you already have the data downloaded before they go to the next screen, then you can easily show that, and they feel like your app is super fast, and you have a more consistent experience, whether they're on their tablet or their phone or their desktop. So, any questions? Yeah.
You were saying on the Apple, the Safari, they had the 5 meg limit. Is there a limit that you would impose on yourself? Like you wouldn't go over X?
I think you look at each app individually and see where it is. Like we're able to shove about 50,000 medications in less than 4 megabytes. So again, a user can go in and that download may take a little bit of time, but that can all happen behind the scenes. And then when it gets downloaded, then all they have to do is type and it's hot. And if they want to type before that, you just make an AJAX call, just like you're normally doing anyway. And then until that database is synced down. So I think you can share a lot of data. There's people that have built apps to do peer-to-peer file sharing using PouchDB. So you streaming files through through WebRTC and using the Pouch replication protocol. So handle a lot of data. Yep.
So without like security concerns, you don't want like tech-savvy users opening up the console,
Right.
Sorry, messing around with your database.
Right. Yeah, security is always a challenge, and JavaScript community and a lot of people that care about security have really made a strong move to embrace that and come up with some sort of RSA algorithms so that you can encrypt things using public and private keys, right? And one of the things that PouchDB has is an ecosystem of plugins, and they have a plugin for encryption so that you can encrypt the entire database in the browser. Now it's a little slower, but you can encrypt the entire database. Another thing you can do is encrypt each message one by one, or the particular fields in that message that you want to be secure. Systems have been able to get very fast about being able to unencrypt that data with a public key. So your server could sign it encrypted, and there's a tool called Keybase IO. Familiar with Keybase IO? That allows you to do point-to-point messages. So if you have a message system and you don't want the server to have the ability to see your data, right? But you want to post it on that server. You can post it encrypted, and then any of your friends that have your public key can unencrypt it when it gets down to their system. So that's pretty much what there is as far as authentication security. Again, you rely on a server for that. We really like what's going on with the JSON web token, or the JOT. Is that the way? I always want to say JIT, but it's JOT is the proper way to pronounce that. And basically you get, once a user signs in, like I was using the tool Auth0, you get an access token that will expire at a certain amount of time, but then you can use that token to make server requests and quickly authenticate that user on all kinds of microservices without having to ping an authentication system all the time. Yep.
Another security-related question is with the ease of replication from your local database to a remote one, is there some way of telling like the remote instance of Couch or something that maybe like a pub sub kind of thing? So like only, even if no matter what they ask for or what they say to replicate, only publish at a maximum this subset of our documents, like based on some token or key that they have. And
yeah, so you can apply in your sync statements, you can apply filtering at the server level or at the client level. And you can, the cool thing about Pouch and Couch is the whole replication specification is built on top of HTTP and HTTPS. So it's very easy to put proxies in front of things. So if their tools can't do exactly what you want to do, you can quickly code up a proxy and be that gateway very, very quickly. But with Couch, if you're connecting to Couch on the server side, you can filter your queries there. Or with Pouch, you can also filter your sync queries at the client side. So depending on where you don't want someone to know or get access to those things, you can control it.
Is there a way to make sure it gets back up to the server? So say it's offline and some data's changed. How do you ensure that there's consistency?
Yeah, so the replicate IO protocol is built to manage that very problem. And basically, from a development standpoint, you just say sync, and it'll immediately start to push data up behind the scenes. And the challenge is when there's a conflict, right? So if we're working on the same record and you push yours up and I push mine, is yours the valid one and mine gets rejected, or is mine going to overwrite yours? And the way that the replication philosophy is that in order for me to overwrite your document, I have to have the most recent revision. So I have to go and get your document's most recent revision, then update it, and then push it up. And that really puts the hands of controlling that into the developer versus just automatically overriding it. And they took that stance because to a user, that's very confusing, right? If you saved a record and then I came and saved a record behind you, and MySQL and those tools today, they'll just overwrite it, and you're like, where did my changes go, right? So they sort of take the approach of not letting anything in unless it knows of that revision. And when you're doing syncing, they'll generate conflict documents, and you can read those conflict documents and manage that programmatically. So, does it make sense? Very cool. Well, thanks again. And